Welcome to the second video in this series of screencasts where I look at exercism and in particular the Scala exercises. Today we have, again, the unit test which we're meant to pass, which sort of tells us the type of problem we're trying to solve. As we can see from the very first statement, we have to write a class called Bob. And from the rest of the tests, we can probably guess that we're meant to define a method called hey. It accepts a single argument, which is a string, and then it returns various strings, depending on the cases. So for a general statement, we're just meant to say whatever. If we're being shouted at, we respond, whoa, chill out. Question, we say sure, and there's a bunch of other cases which we have to consider and pass, such as silence, and silence with spaces, where we say fine, be that way. So let's hop straight into it. So let's try to split. I think there should be a way to split the editor. No idea how to do it. There we go. So we have a class called Bob. The first thing that we should do is, well, let's just write the method hey and accept any kind of greeting. So it's a greeting is a string, and it returns a string again. So put a string, and we just want it to return whatever. When we go back to the testing file, we'll notice that all of these other tests besides the first one have pending on it. So let's see what exactly happens when we decide to run the test. Oh, to avoid conflict, press, I think I've already rebuilt the SBT, so it should be okay. Running. And it's complete. It will say done 1 of 16. So there's 16 tests, everything else is pending. So if we immediately remove pending from the second one and let's just run it again, it will probably come out with an error. I hope it comes out with an error, because that's what it's meant to do. And there we go. Personally, I think it's best to leave the second case for a bit later. And there'll be reasoning to do that. Basically, the reason why I'll do that is I think the second one is actually more complicated. Let's just look through some of the other cases, like this one. Allow questions that end with numbers and respond to questions. How do we respond to a question in real life? We look for a question mark. So how can we extract the very last element of a string? If we run a Scala console, let's try to do that. Let's just think about how, in general, we can take the last element. So in Scala, let's just have a text string that says hello. Oops. Probably. I think that's what you have to do. So we just have a string that says hello. Then if we want to take the very first element, what we can do is we can, well, one way is we can convert it to a list, right? And then maybe select the very first element. So if we go to list, and I think maybe you can do it like that. No, you can't. You probably have to, so like that. No. As you can see, I have no idea what I'm doing. But I think you can do take, maybe, if I remember my Spark. Yeah, there we go. If we use take, then we can take the very first element of the list. Likewise, you can probably realize that the way to do the very last element of a list would be to use take right. And we can get a question mark. I think I actually skipped a step of what I wanted to show you. But we can see immediately here, when we run take right, it doesn't even have to be a list. You'll realize that this is a string and just take the rightmost one. As you can see, I'm not a Scala expert. My Scala knowledge is probably more from Spark than actual Scala, which is why I'm doing this series of screencasts, more for myself than anyone else. So perhaps the way to do this is you could just use a bunch of if statements. So I do know Scala has some kind of pattern matching with cases, but I think we'll ignore that for now and just use if statements because, well, from an imperative world, that is the way you would do it. Based on what we know about if statements and what we will assume would work in Scala, you can probably imagine the answer will look something like this. Greeting, take right, equals question mark. If that is true, then we can return. Response should be sure. Okay, sure. Now we can remove these two, and you should pass both of them because it makes sense that you pass both of them. And let's just run it because, well, those are the two tests that we believe should now pass. And sure enough, now we passed 3 out of 16. Excellent. The next one that we would probably think about, which looks quite easy, is, well, we already can check for a question mark, so why not just check for nothing? Like in this one. And quite naturally, we can fit that in at the top. Use if again, because why not? So if greeting is equal to, well, empty string, then return whatever that means. Fine, be that way. Again, since I unquoted it, we can run it. So let's just unquote that one first, even though you should fail with that one. So we're expecting this one to fail. Should say 4 out of 16 with 1 fail, hopefully. There we go. 4 out of 16 failed 1. And we'll say that whatever is not equal to fine, be that way. Excellent. So let's again start up the Scala console. How might we do stuff to make sure that that is true? So if I, for example, type something like that, what kind of methods are there? So let's look up the strip work. Nope. What about trim? Yes. So if we just trim, then maybe that will give us an answer. And there we go. It looks like it's trimmed. Though it's a bit hard to tell because, well, we're in a console. Like all good things in life, why not just try trial and error? That's what test-driven development is for. Hopefully it will pass. There we go, 5 out of 16. Now we have the hard ones to do. Hard ones being, how do we implement the very last one? This just for ease for myself, let's just delete all these now. I think it's okay to remove them all. Find usages. It's probably a better way to do it than this, but I don't normally use IntelliJ. That's probably something that I should write down that I'm gonna go and have a look at. It's probably a find replace somewhere. Just too stupid to realize how. As I said, I'm a beginner, I'm a noob. So it's okay for now. I will go back and look up how I can do that and refactor the code in a more pragmatic way, as that's what IDEs are for. Anyway, now that I've removed all the pending, let's think about how we can do this one. New Scala console. There's a few things we need to watch out for. Ironically, that's I think that's highlighted. Well, coincidentally, rather. We need to check that everything is uppercase. One way that we might be able to do that is to use the for or in Scala. For or. We type for or, then we can just type something like this is upper. That means is upper, and it will probably tell us that that's true. Does it work for spaces? Why not try it? Oh, missed a dot. No, it doesn't work for spaces. If it's a space, then you'll skip it. The way that I thought of doing this question was really maybe not the best way, but a way that I understood nevertheless. I thought of, what if I stripped out every character? Because again, if we look in the tests, we do ignore the numbers. If we stripped out every character that isn't between A to Z, lowercase and uppercase, and then just run the for all function, for all with is upper, then we can do it. That is the solution I went for, and this is a solution I'm going to show you guys. One way that you can find out how to return a list of all the alphabetical characters is, well, just Google it. You'll find it on Stack Overflow. But here is one of the ways that I think was the most concise and made the most sense to me. So it looks something like this. Remember, double plus is concatenate, so I'm just concatenating stuff from A to Z and capital A to capital Z. As I've already hinted, the way that we're going to do it is we're going to use a filter and then for all. Does this satisfy all cases? For example, one thing that might pop into your mind is, what happens if you run for all on an empty string and is upper? Does that return true? Let's just try that. It returns true, but it shouldn't, right? Because it should be, well, find B that way. There's a few things that why that could happen. It could happen if it was legitimately an empty string. Or, in another case, it could happen if, well, our string only had numbers and punctuation, like 1, 2, 3, as we can see here. So perhaps the if statement that we should consider really has two things it needs to check. It needs to firstly check, is the length of the string after we strip out everything, is it greater than 0? If it's greater than 0, that means it has some kind of alphabetic character in the string. And secondly, once we strip out the string, does it satisfy the condition is upper? And if it does, well then we believe the person is shouting at us, and we should say, tell them, whoa, chill out. So let's do that now. If greeting filter. I'm hoping this works. I haven't actually really tested it. Alpha contains. So this is the statement to filter something and check whether it is in the top one. So just yeah. I don't know if we need to list or not, so let's give that a go. So greeting filter alpha contains. Right, then for all is upper. If that is true, then we can go ahead and say return. Whoa, chill out. Let's see what happens when we just run it like this. Remember, we do have to add an additional condition. It failed 10 tests. Looks like I spelled whoa wrong. Is that right? Yeah, I did. Okay, let's just rerun that. It failed 2. Which 2 did it fail? While chill out is not equal to sure. Okay. And while chill out is not equal to whatever. So that's there. We see only numbers. Yep, that's the one that I said will probably fail. And what is this one? Same one. Okay, excellent. Boolean commands are the same. You can just use an and sign. I think single one and double one is the same in Scala, I hope. What is it, length? Yeah, length. Greater than 0. Then we're done. Let's run that. That should be it. And look at that, we're finished. Excellent. So there we have it. That's the solution. Well, that is my solution. It may not be the best example of Scala code, but it works for me. I've managed to use some of the trim, take right, filter for all, and length, and it contains statements, so I'm very happy that it worked out. I think some of the improvements that I would like to make, and I'll probably have to go back and look, is firstly, how do you use find, replace, or the refactor, which I see right here, and it looks really cool, but I have no idea what it does. How do I use that in IntelliJ? So let's just write that down. How to use refactor in IntelliJ. And secondly, what about switch or case statements? Case statements, which I definitely know, or pattern matching, which I definitely know exists somewhat in functional programming languages like Haskell, and it definitely exists in Scala. Didn't do it here. That's something that I should think about next time. Maybe when I come back and revisit it after I've done a few more exercises. That's my solution for Bob. What's yours?